So before we begin our lesson, let's do a quick review like we did yesterday. Scoot your chair in. Everybody scoot your chair in. Remember, if you're too far away from your desk, you can't reach your stuff. Okay. What would I do if I wanted to know about what 463 times 2 equals? Zari.
You would estimate the
I would estimate. If I see a word problem and it says about how much, are we finding an actual answer? No. So I would estimate. Well, when I estimate, am I going to estimate my one-digit number, class?
No.
No. If I estimate my one-digit number, well, 2 is closer to 0. And then I get, no matter what, the answer 0. But that's really not close to anything. So I always, when I'm multiplying by one digit, I always estimate my larger factor. When I'm multiplying by one digit, I always round my larger factor. What is step 1 of estimating? What is step 1 of estimating? I'm going to pick some sticks. Keep your hand up. But everybody needs to know these steps. If you don't know these steps, you need to make sure you do because you'll be using them. Okay, what is step 1, Victoria?
To circle and underline. Circle the greatest place value and underline.
That's not. What is step 1? Who can help her out? That's close, but. Carla?
To round the place that you need to estimate.
What do you mean by round the place I need to estimate? What does that mean? We use the same words every single time. Who knows those words that are in your math book that we use every single time we say this? We use the same exact words. Kingston.
Circle the greatest place value.
Do we always circle the greatest place value? Those are not the exact words. Zadie.
You underline the place to be.
That's not. Aaron.
Circle the digit to the place to be.
Circle the digit in the place to be rounded. Those are the exact words from the math book. Those are the exact words that I use every single time. So there is no reason to change up the words. Circle the digit in the place to be rounded. Well, Aaron, if it doesn't give us a place to be rounded, then which digit do we know, which place do we know we're rounding to? Every single time, no matter what the number is? The what? Who can help her out? If it does not give us a place to round to, then we know we're rounding to what, Michaela? The greatest place. So, Michaela, what is the greatest place in this number? What is the greatest place? The hundredths. What is the digit in the hundredths place? The 4. So I'm going to circle the 4 in the place where we're rounding. What is step 2 when we are rounding? Cullen, what is step 2? We use the same words every single time. They're the exact words that were written in the book. Mason? Underline the digit to the right. What digit is to the right of our circle digit? 6. What place is that in? Just for fun. The tens place. Good. Okay. Remember, step 1. Circle the digit in the place to be rounded. If it doesn't tell us what place to round it to, we know that means the greatest place value. Step 2. Underline the digit to the right of the circle digit. What is step 3? The exact words that we use every single time. What is step 3, Michaela?
If the digit in the tens place,
That always, no matter what the number is, always the tens place.
if the underlying digit is 5 or more, we add 1 to the circle digit.
Good. If the underlying digit is 5 or more, we add 1 to the circle digit. Is that all of step 3? There's another part to step 3. We just have to choose which part to follow. What's the other part? Who can help her out? She used the exact right wording. There's just another part, and we choose which of these parts of the step to follow. Cullen?
If it's 4 or less.
If what's 4 or less?
If the underlying digit is 4 or less, we let it rest.
What does that mean? Is that what the math book said? Did the math book say let it rest? What does that mean, letting it rest? If I didn't know math, or if you were trying to teach me this, I would be like, what do you mean let it rest? It's a number, it can't rest. Zari, can you help her out?
If you
Use the same language, please, the same words. That's how we get confused. Use the same exact language straight from the book. The book does not say if you. The book does not say if you. You need to use the exact language. This is why we get confused. Because you're not following the patterns. You're not listening for the patterns. You're not memorizing the steps. What is the other part of step 3? Michaela told us if the underlying digit is 5 or more, add 1 to the circle digit. We're going to use the same exact language. We're just going to change a few things. Smith.
If the underlying digit is 4 or less, you don't do anything to the circle digit.
If the underlying digit is 4 or less, keep the circle digit the same. So, Michaela, you told us if the underlying digit is 5 or more, we add 1 to the circle digit. So what does that mean for this number?
The circle digit is going to go up by 1.
So the circle, we're going to add 1 to the circle digit. So that 4 is going to become a 5. What is step 4? Exactly from the book that we say every single time. What is step 4? Aaron.
Turn all the numbers after.
Not all, this whole thing is a number. That's not what the book says. Zadie?
Turn all the digits after the circle digit to 0.
All of the digits after the circle digit become 0. Zadie, how many digits do we have after the circle digit? 2. So how many zeros are we going to have in our answer? 2. What is step 5? This is one we added, but we still use the same language every single time. Smith, what's step 5?
If there are any digits before the circle digit, we bring them down.
So we don't bring them down. They stay the same. I think you guys need to go back to chapter 1, lesson, I think, was it lesson 2? No, it was lesson 5. And you need to memorize those steps. No, it wasn't lesson 5. Yes, it was lesson 5. You all need to go back to chapter 1, lesson 5, and memorize those steps tonight. It's on page 38. You might want to give yourself dog-ear it so you know where it is. Page 38. Everybody go and find page 38. Dog-ear the corner. That means fold down the corner. You might want to do a big fold so that you can find it, because you guys have got to be memorizing these steps. We use the same language every single time for a reason. Because if I change the language I use every time, are you going to remember exactly what to do? If you're hearing 4 different ways to do it, are you going to remember? No, you're going to mix up those words and those ways and it's all going to get confused. That's why we use the same language every single time, especially in math and science. where there's exact processes you have to go through. It's exactly what you have to do. You can't change it. I don't know, I feel like I did not see everybody go back to page 38 and fold down the corner. And now we have to wait for you because you did not do that when I asked you to. So go back. Did everybody? Zadie, did you go back to page 38? Mason, did you go back to page 38? Mason, I have to add something to yours because you weren't here when we did it. And we added step 5 to that page. So try to remind me to do it later, okay? Kellen, did you do it? Michaela, did you do it? Ethan, did you do it? Did you do it? Kingston? Why do you not have step 5? You were here. Okay, I'll have to figure it out. Victoria, did you do it? Tell me. Yes. Yes, what? Loudly. Aaron, did you do it? Yes. Smith, okay. Zari, did you do it?
Yes.
Yes, what?
Yes, I did it.
Yes, ma'am. Carla, did you do it?
Yes, ma'am.
Okay. Okay. Now, we just rounded, but are we done with this problem? No, because what do we have to do next? I'll pick a stick, actually. Zadie. We rounded, but are we done solving this? About what? 463 times 2 is about what? Is it about 500? No, so what do we have to do next to solve this? Come on, Zadie, what do we have to do to solve this? Does this solve anything? We're trying to find out the estimated answer to 463 times 2. Well, we just rounded our larger factor, so what do we have to do now? Michaela? Multiply. So I have to bring down. Can I solve it without doing that, Zadie? No. Come on, it's common sense. Just, you gotta wake up. So, Michaela, how do I solve this? What do I use to solve this? What strategy? I'm talking about it every day. Who can help her? What strategy do we use to solve this? Zadie?
Basic facts and patterns.
Basic facts and patterns. So when we use basic facts, now we have another process. Step 1 is to do what?
Find the basic fact.
Find the basic fact. What is the basic fact?
5 times 2.
5 times 2. Step 2 is to do what?
Solve the basic fact.
Solve the basic fact. 5 times 2 is what?
10.
Step 3. Cullen.
Count how many zeros.
Count how many zeros. How many zeros are there, Cullen?
1, 2.
Step 4. Mason.
Add the zeros.
Do we add the zeros? 10 plus 0 plus 0? Victoria?
We replace the zeros with our number.
Michaela?
We place our zeros at the end of our product.
We place our zeros at the end of our product. Michaela, we had 2 at the end of our factors, which means what about the end of our product?
It's going to have 2 zeros.
It's going to have 2 zeros. Then we put our commas. So that means 463 times 2 is about what, class?
1,000.
1,000. Come on, guys. The steps, the language is very, very important in math. Because is there another way to do this? No, this is the only way. So that is why it is so important to have the correct steps and have the correct language. Because math has exact answers. It's not like reading, where you can kind of make inferences and interpret it however you want to. Math, you can't do it however you want. There's only one way. I mean, there's strategies you can use, but there's only one way. There's only one right answer. Is there any other answer to 500 times 2 other than 1,000? No. Can 463 times 2 be about anything other than 1,000? No. So that's why in math you have got to make sure you have the exact steps with the exact language. Otherwise, you are going to end up with an incorrect answer. So make sure that you are doing that. Okay, turn to page 285. Read the sentences under the title. Zari, loud and slow.
The word about tells you to estimate.
Keep going. Oh, you muted yourself.
When you estimate the product of two-digit factors, it is helpful to round them both.
Sorry, you left out one of the twos. So you have to use every word. When you estimate the product of two-digit factors, it is helpful to round them both. So when we did one-digit factors, we only rounded one of the factors, right? Well, when we round two-digit factors, how many are we going to round? Show me, don't tell me. When we estimate two-digit factors, how many are we going to round? Show me, don't tell me. Don't look at everybody else. That's not your answer, that's their answer. Aaron, I need an answer. When we estimate two-digit factors, how many are we going to round? Show me, don't tell me. Zari, can you read that last sentence again? Aaron?
Yes.
Okay, go ahead.
When you estimate the product of two-digit factors, it is helpful to round them both.
So, how many are we going to round when we have two-digit factors that we're trying to estimate? 2. That's exactly what the sentence said. So today's lesson, we're going to be rounding both, head up, which means we can still use basic facts and patterns. Yesterday's lesson, we still couldn't use basic facts and patterns. We had to do something extra. Today, we get to use basic facts and patterns. So everybody, finger or pencil on example 1. You need to be in math class right now, not wherever some of you are. So your brain needs to be here. It's like our rules. Where is it? Concentrate on what is happening now. Not what you're having for lunch, not the TV show you saw last night, not where you'd rather be, because we're in math. So your brain needs to be here. Okay, everybody, finger or pencil on example 1. Read in your head while I read out loud. A hamster sleeps 14 hours each day. About how many hours does a hamster sleep in 3 weeks? Okay, so first we find our question, which is, about how many hours does a hamster sleep in 3 weeks? I notice something that's a little different. I see the word about. If I see the word about, am I finding an actual answer? Show me. No. I am doing what? Mason? Estimating. So now I know I'm not finding an actual answer. I'm going to be rounding. But let's keep reading because I still need to know what my numbers are and what my operation is. About, so now I'm looking for the answer unit, which comes after how many, or whatever means the same thing as how many. I see hours. I see the noun hours after how many, which means hours is my answer unit. Whatever my answer is going to be a number of hours. If I keep reading, I see, does a hamster sleep in 3 weeks? Well, I see a number, but I'm not exactly sure if it's important yet. If I stopped here and said, oh, it's 3, so I know it's going to be 14 times 3? You're going to be wrong. Because let's go back to the beginning and see, is our other unit weeks? A hamster sleeps 14 hours. Well, I see 14 hours, so I do know that's important because that's my answer unit. Each day. Each tells me I'm multiplying or dividing. And then the noun after each tells me my other unit, which is day. If I keep going and I say 3 weeks, well, there's my other number, so that must be my other unit, 3. That must be my other number, 3 weeks. But are weeks and days the same thing? Are weeks and days the same thing? Show me, don't tell me. No. But I don't see a number of days. But if I know there's 3 weeks, can I figure out how many days there are? Yes. Because I know there are how many days in 1 week. How many days are in 1 week? Michaela? 7. I can quickly do that basic fact in my head to figure out what my other factor is. 3 weeks, there's 7 days in each week. That means 3 times 7 is 21. So 3 weeks is important, but it's not my other number because 3 weeks equals how many days, Michaela? 21 days. So it's not so it's not 14 times 3. It's 14 times 21. We've seen problems like this, and you guys are letting it trick you because I think what you're doing is instead of actually figuring out what each unit is and then looking for a number of the unit, you're just looking for numbers. You can't just look for numbers in word problems. Some of them it works, but does it work every time? If we just saw the number 14 and 3 and we knew we're doing a chapter on multiplication, so it's like, oh, we're doing 14 times 3. Would you be right? No. That's why you have to closely read the word problems to see, is it those two numbers or is it something else? So now we know our equation is 14 times 21. Oh, I forgot. If we know we're doing we have 21 days and the hamster sleeps for 14 hours each of those days, is he going to end up sleeping more or less than 14 hours? Class?
More.
More. So we are multiplying. Forgot about that part. So now we know our equation is 14 times 21. But are we solving 14 times 21? Zari?
No.
No, because the problem said what?
The problem said about how many hours.
Good. The problem said about. So that means our actual equation is 21 times 14, but that's not what we're solving. We have to round. This tells us to round to the nearest 10. Well, we know no matter what, if we only have 2-digit numbers, can we round to anything other than the nearest 10? Can you round to the nearest 1? No. Otherwise, it would be the same exact number. So, that means we need to round to the nearest 10. Michaela, 21 rounded to the nearest 10 is what? 20. 14 rounded to the nearest 10 is what? Ethan. 14 rounded to the nearest 10 is what? 10. So that means our estimated equation is what, Kingston? 20 times 10. Well, now I can use basic facts and patterns. But because we're setting it up differently, I'm going to go backwards this time. I'm going to start with step 3. What is step 3? Smith? What is step 3 when we're doing basic facts and patterns?
Solve the basic fact.
That's not step 3. That's step 2. Zari, what is step 3? Think of your steps in order. Step 1 is this, step 2 is this, step 3 is, oh, step 3 is this. What is step 3? When we're solving basic facts and patterns. Come on, guys, I just said it like 3 times. Zadie, count your zeros. How many zeros do I have? 2. Step 4 tells me the same amount that are at the end of my factors are going to be at the end of my product. So Zadie, how many zeros are going to be at the end of my product? 2. The reason I'm doing that backwards is because when we're lining things up, we start at what place? The ones place. The answer to my basic fact is not going to be in the ones place, so I'm just going backwards. I'm counting the zeros at the end of my factors first, and then putting them at the end of my product. That way I know exactly where the answer to my basic fact goes. Now, step 1, what's the basic fact? Aaron. 2 times 1. We're going for the most basic of basic facts. 2 times 1 is 2. So Aaron, that brought up a good point. When we're looking for basic facts and patterns, we are looking for the most basic. So yes, 2 times 10 is a basic fact, but we already counted those zeros. So make sure you're looking at the most basic of basic facts. 2 times 1 is an even more of a basic fact than 2 times 10. So does everybody understand what I mean by that? Because if we did 2 times 10, we'd have too many zeros. So a hamster sleeps about how many hours? Mason, I want you to say this sentence, but I want you to fill in the blanks with the correct numbers.
So a hamster sleeps about 200 hours and 41 days.
Good. Oh, there's a little more to the sentence.
Or 3 weeks.
Good. So a hamster sleeps about 200 hours in 21 days or 3 weeks. Now, this is something we won't be able to do every time. But let's look at this last little bit. Since both factors were rounded down, 20 is less than 21, 10 is less than 14, the estimate is less than the actual product. So remember that from when we did estimation of 1-digit numbers. If you round it up, which means your estimated factor is larger than your actual factor, that means your estimated product will be greater than your actual product. If your estimated factor is less than your actual factor, your estimated product will be less than your actual product. But with multiplication of double-digit numbers, sometimes it's a little different. Because how many factors are we estimating now? How many factors are we estimating now? Carla?
2.
2. Do you think about this, that it's always going to work where we are rounding up or rounding down with both factors? Or is it possible to have to round one up and one down? What do you think? Zari?
I think it could be possible that one of them could be rounded up and one of them could be rounded down.
It is. We will see that. So if you round one up and one down, are you really going to be able to tell if it's greater than or less than the actual factor? The actual product without solving? No, you won't. If both of them get rounded down, then you can say the estimated answer is less. If both of them are rounded up, you can say the estimated product is greater. But if one's rounded up and one's rounded down, you can't say without actually solving the problem. Okay, so let's move on to example 2. Okay, everybody, finger or pencil on example 2.
Miss Davis is at the.
Please make sure that you are focusing. I do not want to have to do an extra day of estimation. And I know that you guys probably do not want to do an extra day of estimation either. Okay. Okay. Miss Kaplan said that too, so. Miss Kaplan said that too, so that works perfectly. Okay. So everybody, finger or pencil on example 2. Please make sure you're here so that we don't have to do another day on estimation. This should be a lesson that we get through like this, okay? Because we've already done it, we're just adding an extra step. But we're still doing the same thing in that step, it's just we're doing it again. Example 2 says, Tanya spends 35 minutes playing at the park each day. About how many minutes does she play at the park in 38 days? Well, first, I underline my question. I already know, I see the word about, which means I'm doing what, class?
Estimation.
Estimation. Then I look for my answer unit. I see how many, so I don't even have to figure out any words that mean the same thing. I see the now minutes, so there's my answer unit. I see, does she play at the park in 38 days? But should I say that's my other factor right now? No, because what if it's like example 1, where it's like, how much does she play in a month or something? Or in a year, I don't know, whatever. Tanya spends 35 minutes playing at the park each day. Well, I see my answer unit with a number, so I know 35 minutes is part of my equation. Playing at the park each day. Well, I see each. That tells me I'm multiplying or dividing. And then right after each, I see the noun day, which is my answer unit. Awesome. My other unit, not my answer unit. My other unit matches that unit after the other number. So I don't have to do anything like in example 1, where I had to figure out how many days were in 3 weeks. So I know 38 days is the other piece of my equation. Now, are we multiplying or dividing? Well, if she plays 35 minutes each day for 38 days, our answer unit is minutes. So is she going to end up playing for more or less than 35 minutes? Class? More. So we are multiplying. I know in multiplication it does not matter what order my factors are in because of the commutative property. So I know it's 38 days times 35 minutes, or 35 minutes times 38 days. Yes, Victoria? I can't hear you.
When we circle about, and then we put estimation at the top, do we write yes?
Yes. That's fine. Or EST might be better because I'm trying to think there might be. EST is an actual abbreviation for estimation. Or I think. I don't know, maybe it's not. But EST. If you want to write EST instead of estimate above about, that's fine. So we know we're trying to estimate 38 times 35, not solve it because our problem said about. So, step 1, we round each factor to the nearest 10. Carla, 38 rounded to the nearest 10 is what?
40.
40. Good, because that digit to the right of the digit in the place we're rounding to is 5 or above. So we add 1. Please do not forget that. Some of you on your tests rounded down every single time, even though you weren't supposed to. So make sure that you are rounding correctly. You're not always rounding down. Sometimes you might have to round to the higher number. You have to pay attention. Very good, Carla. Okay, 35 rounded to the nearest 10 is what, Zadie?
40.
40. We also have to round that up. Ooh. I rounded both of my factors up, so I already know what about my estimated product. I rounded both of my factors up, so I already know, no matter what about my estimated product. Michaela?
It's going to be greater
Then what?
your actual product.
It's going to be greater than my actual product. I already know that. So now I know 38 rounded to the nearest 10 is 40. 35 rounded to the nearest 10 is 40. So Michaela, what is my estimated multiplication problem? 40 times 40. I'm doing a problem where I can use basic facts and patterns up and down. So let's start with the zeros. Victoria, how many zeros do I have? 2. which means what? If I have 2 zeros at the end of my factors, what does that mean?
We're going to have 2 zeros in your product.
Where in my product? The beginning, middle, end, randomly? At the end. Now, I already did steps 3 and 4, so I can go ahead and do step 1. Kingston, what's my basic fact? 4 times 4, and 4 times 4 equals? 16. Which means 40 times 40 is what, class?
1,600.
1,600. Sorry, please read the sentence underneath the number 2, but fill in the blanks for us.
So Tanya spent about 1,600 minutes playing at the park.
Good. So Tanya spends about 1,600 minutes playing at the park. Mason, can you read this next sentence and fill in the blank? Read it, fill in the blank in your head first. Then go ahead and read it and fill in the blank for us.
Since both factors were rounded up, the estimate is higher than the actual product.
Well, let's use those math words. Remember, greater than or less than are our math words. So read it again with the math words.
Since both factors were rounded up, the estimate is greater than the actual product.
Good. Since both factors were rounded up, that means the estimated factors were greater than the actual factors. The estimate is greater than our actual product, because 35 times 38 would look like this, but 40 is a bigger number, and 40 is a bigger number, which means we have all this extra space that's in that answer. That's what that diagram means. Okay, does everybody feel good about this? We're doing the same thing we did in the last chapter. We're just adding an extra step. That extra step is exactly the same as the first step, rounding the first factor. We're just rounding a second factor. So before we rounded one factor and then solved using basic facts and patterns. This time we're rounding 2 factors and then solving using basic facts and patterns. Yes, Victoria.
So basically what we're doing, I listened to what you said too. But 40 times 40, you just make the zeros go down and then you do 40 times.
Yes, we're just kind of flipping the process. Where before we did the basic fact first, and then we added the zeros. Since we're lining it up and down, that means we have to line up our place values, right? And it's much easier to line up your place values when you start in the ones place. Well, you know, if you're estimating multiples of 10, what's always going to be in the ones place? Anytime you multiply by a multiple of 10, what is always going to be in the ones place? Everybody who has their hand up all at once.
0.
0.
So that means we're always going to have a 0 in the ones place. So why not just start with the zeros so we can line it up properly? That's all we're doing. We're adding a second time rounding, and we're just flipping the way we do basic facts and patterns. We're finding the zeros first, then solving the basic fact. Just make sure, since you're doing the zeros first, your basic fact does not include 10. Okay? Does everybody understand what I mean by that? Instead of finding the basic fact, a number times 10, think of it as that number times 1. Okay? The simplest of basic facts is what you're looking for. Okay, helper number 1. You should be looking at the guided practice. The directions say estimate. Circle whether the estimate is greater than or less than the actual product. Well, if we have that extra direction, circle whether the estimate is greater than or less than the actual product, we know that means we're going to be rounding each factor the same way. We're either going to be rounding them both up, so they're greater than the actual factors, or we're going to be rounding them down so that they are less than the actual factors. That won't always happen, but it will happen in your math book if that is the direction. Does everybody understand what I'm saying by that? So that's a way to self-check. If you have this direction, circle whether the estimate is greater than or less than the actual product, and then you get to the estimation, you're like, wait, but I rounded this one up and this one down. How do I tell? That means, oops, I better go back and check my estimation. Does everybody understand what I'm saying by that? If you have this extra direction, it means you're going to be rounding both factors in the same direction, either up to a greater factor or down to a lower factor. So 57 times 25. Smith, we have to round how many factors?
2.
2. So 57 rounded to the nearest what place?
Tens place.
Is what?
60.
60. And 25 rounded to the nearest 10 is
30.
30. Oh, let me also tell you, this won't really come in this lesson today, but in later lessons it will. If you have two factors that have a different number of digits, you have to round to the greatest place in the smaller number. Does everybody understand? Because if you have 163 times 25, you can round 163 to the hundredths place, but can you round 25 to the hundredths place? No. Which means you have to round them both to the same place value, which means you'd have to round 163 to the nearest 10 and 25 to the nearest 10. You won't see that today, but you will see that in later lessons. Okay? You have to round each factor to the same place, which means if you have one factor that has less digits, you have to round to that factor's greatest place value, not the one with more digits. But we'll see that. Might be in Friday's lesson. I don't know. We'll see. Okay. So Smith, now we have our estimated equation, 60 times 30. What should we do first to make sure that we get all of our digits in the right place?
Start multiplying the ones place.
Well, are we multiplying the ones place though? Did we multiply the ones in any of our other problems?
No.
No. So are we going to start multiplying the ones place?
No.
No, because we're just using basic facts and patterns. When we use basic facts and patterns, do we multiply the ones, tens, hundredths, and so on?
No.
No. So what should we start with? Should we start with the basic fact, or should we start with counting the zeros?
Counting the zeros.
Okay, how many zeros are at the end of our factors?
2.
So how many zeros are going to be at the end of our product?
2 zeros.
2. Remember, when we're setting them up and down like this, we really need to start with the zeros so that we can get our answer in the right places. Now I can do the basic fact. What's the basic fact, Smith?
6 times 3.
And 6 times 3 equals?
18.
18. So that means, Smith, 60 times 30 is?
1,800.
Which means 57 times 25 is about?
1,800.
Good. Now we need to figure out, is this estimated product, 1,800, greater than or less than what our actual product would be? Well, which direction did our factors get estimated, Smith? Were they greater or were they less than our actual factors?
Greater.
Greater, which means our estimated product is?
Greater than our actual product.
Greater than our actual product. Good. Very good. So does everybody understand this lesson? The only difference between this lesson and what we did in chapter 4 is that we are estimating an extra factor. We're doing it the same way. Are we rounding it any different way? No. We're rounding it the exact same way we always round. We're just adding an extra time of rounding. And then when we get to basic facts and patterns, we're just doing the zeros first so that they line up. Okay, let's look at the independent practice. Numbers 2 through 7, you're doing the exact same thing you did in the guided practice. Now look at numbers 8 through 13. Those are sideways, but we're estimating. So do you have to set them up and down? No. You do, though, on that line, have to write the estimated equation along with the estimated answer. Does everybody understand what they need on the line for numbers 6 through 13? You need the estimated equation and the answer. on the line, the estimated answer. You are not finding actual answers. Look at number 14 through 16. These are those ones where you have to figure out, okay, there's only one number that A can be. Using my basic facts and patterns and mental math, what does that number have to be? How many digits do you think it's going to be each time? Mason? 2. Because we're working with 2-digit times 2-digit numbers. So that means that answer each time for number 14 through 16 is going to be a 2-digit number. What do you think is going to go in the ones place each time? Victoria? A 0. So you're basically just finding out what's in the tens place, which means what basic fact can you do to get that answer. Okay, turn to the back. Oops. Turn to the back. Lucky you, they already have the place for your equation. So you don't even have to write it, but you do have to fill in those blanks. Fill in the blanks. Remember, are you filling it in with actual factors from these problems? No, you are finding estimated factors. Numbers 21 and 22 are critical thinking. 21 is critical thinking with numbers. 22 is critical thinking with words. You do not need a separate sheet of paper for this independent practice. Let's look at the homework. Let's look at the homework. Numbers 1 through 4. Lucky you again, they're giving you the blanks. So all you have to do is fill in the blanks with the correct numbers. Number 5 and 6, you don't have blanks, so you need, everybody listen, number 5 and 6, you need the actual equation, the estimated equation, the estimated answer, and the unit. So it's those same things we always do, you just need to have the actual equation and the estimated equation. You do not need the actual number, obviously. Because the actual product, just the actual factors, because you don't know how to solve that yet. So equation with the actual factors, equation with the estimated factors, estimated answer, unit. Numbers 7 and 8, just fill in the blanks. Make sure if there is an extra question about explain something, make sure you explain it. That's why they give you those extra lines. Number 9, you will need to solve. You can solve it on the paper. You have space. Any questions about independent practice or homework? You do not need a separate sheet of paper for either one, because everything can be solved on the lines using basic facts and patterns, or that test practice question you have room, you can solve it there since you're not having to regroup and all that stuff. Yes, Zadie.
For the independent practice, do you want us to solve number 22 first?
Okay. Any questions about independent practice or homework? Okay, go ahead and begin. If you end up with questions, please